Today we're going to be talking about a method called Gauss-Jordan matrix reduction. Now it sounds really scary, but I promise you, it's not nearly as bad as it sounds. In this unit we've been looking at systems of equations. Systems much like this one. We talked about what they are, where you can find them in nature, and how we use them. Over the unit we've talked about different ways to solve these systems of equations. What I'm going to show you today is a method that is much simpler and used by a lot of college-level mathematicians. We have investigated We've previously investigated how to represent a system of equations using a matrix. We used what's called an augmented matrix. We took each coefficient or number that is multiplied by each variable and we plugged it in as our different indexes on a matrix. When we were done with that, we had this column here, and here we plugged in the answers on the other side of the equal sign. So we know that this line basically represents each one of these equal signs in our system of equations. So what we're going to do now is take this system of equations, take what we've already learned, and plug it into this matrix. And it's fairly simple. We'll take each coefficient and throw it into the matrix so that we end up with this. Now, if you look at your handout, you'll see that I also have this system of equations on the handout. As I solve it on the board, you can follow along in the handout and see what I'm talking about. If you have any questions, if you don't understand, please raise your hand and ask me. I am more than willing to answer them for you. I didn't understand this stuff the first time I was taught it either. The first thing we want to do is look at our first column. This column here, we want to change it. And we want to change it to a form that has a 1, a 0, and a 0, as you can see in the handout. The quickest way to do that is to start with our 1. We want to get a 1 in the top space. Well, do we have a 1 anywhere in this column?
Oh,
Yes?
down there at the bottom.
Yes. The bottom row has a 1. What's the fastest way to move that up to the top?
I'm not sure.
Well, if I have one thing over here, and I have one thing over here, and I want them to be in the opposite position, what would I do?
Switch them?
I would just switch them. We're going to do the same thing. Now remember, when we deal with a matrix, we can't just do a number for a number. We can't switch a number for a number. We have to think in terms of rows and columns. Well, we're not going to move this column anywhere, so we're going to switch rows. So what we'll do is we'll take this bottom row, the 1, the -4, the 3, and the 3, and we're going to put it up here where the top row is, and then we're going to do the opposite. We're going to take the top row, and we'll put it down here where the bottom row is. This gives us a new matrix. Oops, that's the old matrix. A 1, a -4, 3, and a 3. Our middle row doesn't change. We still have 4, 3, -2, and 9, but our top and bottom rows have changed and switched places. -4. Now that we have our 1 in position, that smudge. Now that we have our 1 in position, we need to change each of these to a 0. What we need to do is use this first row that is now in the correct position to create what you would call an equal and opposing force to each of these numbers. Now if I had a balance or a scale, one of the old-time scales where you have something on this side and something on this side, and I had 5 things over here, the scale would tip to one side, right? How would I balance it out?
Well, you gotta have 5 on the other side.
Right, I need to put 5 on this side. Well, when we're looking at numbers, one side is positive, the other is negative, and the balance is going to be 0. So if I have a positive 4, what is my equal and opposing force going to be?
Oh, a -4.
Correct. It will be a -4. So how do we change 1 to -4? Now mind you, we're only going to be using the elementary operations. You can only add if you add rows. You can only multiply if you multiply across the row. What's the quickest and easiest way to change 1 to -4?
Multiply it by -4?
That would be the quickest and easiest way. So let's do that. We're going to multiply it by -4, but remember, because we're dealing with a matrix, we're going to do the entire row. So we'll multiply this row, and on your handout you'll see the result. it becomes negative 4. Negative 4 times 4 is times negative 4 is positive 16. 3 times negative 4 is negative 12. And 3 times negative 4 again is negative 12. So our new row becomes negative 4, positive 16, negative 12, and negative 12. Now, we've changed that, but we don't want to leave it there. We want to add it to our second row. Why? Because we're going to use the positive 4 and the negative 4 to balance each other out and create a 0 right here. So when we add that new row, we get the following result. Negative 4 plus 4 is 0. Positive 16 plus 3 gives us 19. Negative 12 plus negative 2 gives us negative 14. And negative 12 plus 9 gives us a negative 3. Now that we've done the 4, we need to do the 2. So that we end up with the column we're searching for. We want 1, 0, 0. We need to change that 2 into a 0. If negative 4 changed 4 into a 0, what's going to change 2 into a 0?
A negative 2.
Negative 2, exactly. So we'll go through and we'll add this row again, or rather multiply, excuse me. We will multiply this row again by negative 2. Okay? So we get a negative 2 here. Negative 4 times negative 2 is?
Negative 8.
No. A negative times a negative is a positive, remember.
Oh.
So negative 2 times negative 4 is positive 8. You need to be careful when you're dealing with signs. If you make a mistake with a sign, the whole thing is going to mess up. So we have a positive 8, and then 3 times negative 2 is negative 6, and again 3 times negative 2 is negative 6. So we have our new row of negative 2, positive 8, negative 6, and negative 6, which you can see in your handout. And we're going to add it to this bottom row. When we add it, negative 2 and 2 balance each other out. We get a 0. Now you'll notice our first column is exactly the way we want it to be. We have a positive 8 plus a negative 3. That gives us positive 5. A negative 6 plus a positive 1 will give us negative 5. And a negative 6 plus a negative 4 gives us negative 10. We finished the first step of the Gauss-Jordan reduction method. We've changed this column to be exactly what we want. The next step is going to be change the middle column to a form of 0, 1, 0. Now some of you have probably noticed I multiplied this row by negative 4 and negative 2, but I didn't change it right here. Why do you think I did that?
I don't know.
Well, what was the goal for this step? What did we want to change this column into?
1, 0, 0?
Correct. If I had left it as that row times negative 4, what would be right here where the 1 is?
A negative 4.
Negative 4, but that's not what we want. So what we will do is we will alter this row to change the other rows, but this row is going to stay the same. Now our next step, we want to put a 1 right here in the middle. Now my recommendation would be, let's look at this matrix and see if there's anything easy that we can spot that we can do right now. Does anyone spot anything that might be simple to do at this moment? Any division or multiplication that we can do to make this look easier than it looks right now?
Well, the bottom row, those are all, they can all be divided by 5.
That's correct. The bottom row is divisible by 5. So what we'll do is we'll go ahead and do that. We change that and we get 0 divided by 5 is 0. 5 divided by 5 is 1. Negative 5 divided by 5 is negative 1. And negative 10 divided by 5 is negative 2. Well, we have a 1 in the middle. Just like we had a 1 down here at the bottom, if we have a 1 down here at the bottom and we want to put it right here in the middle, what do?
Oh, you can switch them.
Yes, exactly. We switched them. So we'll switch these two rows and divide this row by 5. This gives us a new matrix. Pardon me. The middle row will become 0, 1, because we've divided by 5, negative 1, and negative 2. Now we're going to use this to change the top and the new bottom. The new bottom is our 0, 19, negative 14. In fact, let's go ahead and look at it like this.